Hello everyone, welcome back to Agi's weekly webinar, Skill 3. As you can see, today we're using English in our session because we have an international speaker from an international company. We're having a guy from Amazon Web Services or AWS with the theme hosting and scaling multiplayer games on AWS. Okay, now let's say hello to our speaker, Mr. Nirav Doshi.
Hello,
Hi,
everyone.
hello Nirav. How are you doing?
I am good. Thank you. How is everyone?
Yeah. I hope they're all good. And
Nice.
could you tell us a bit about yourself and what you do in AWS?
Sure. So my name is Nirav Doshi, and I'm part of a team called the APJ Game Tech team. So I work across the APJ region, the Asia Pacific region overall. I am based out of Sydney, Australia, but I've been working across Southeast Asia, across Australia, New Zealand, and India as well.
Okay, great. So you're now in Sydney.
That's correct.
So it's what 6 p.m. right now?
It's 7 p.m.
7 p.m. Okay. So it's
That's
4
okay.
p.m. in Indonesia. Yeah.
Yes.
Yeah.
Nice.
Okay, thank you, Nirav, for your time. And so, without further ado, Nirav, the virtual stage is yours.
Thank you. Um, Thank you, everyone, for joining in this evening. We're going to discuss hosting and scaling multiplayer games on AWS, and we'll start with a little introduction about AWS for games. What is AWS for games? We'll then move into game server hosting and try to understand what is required for game server hosting and how does AWS help there. So there is some basic information about how game server hosting is performed, as well as what are the usual challenges that you would see, and then how does AWS infrastructure help you around those problems. We'll also see a service that we have called GameLift. This is a fully managed, dedicated game server hosting solution that AWS offers, and we also have an example solution that you can start quickly using without having a lot of underlying AWS experience. Um, First, greetings and thank you again for joining our talk today. I've been with AWS for more than 6 years, and before AWS, I've been in games for about 10 years, developing games as well as operating and managing and leading teams of developers. I worked in online casinos as well as casual games and mobile games. So I really enjoy the domain, the industry overall. Um, I do play a few really popular games, but I'm kind of old fashioned. You may think I still like Mafia 2, which is one of my favorite games, and I do like Sniper Elite 2, Battlefield 3, Lumosity. If any of you play any of these games, um, I can relate to you. I'm not currently playing any game as such. I do play some chess online, as well as I play Lumosity regularly on a daily basis on my mobile, but I'm not actively playing any games per se. I'm joined by Antoine. Antoine is our game tech BD. He's in Singapore and he looks after the ASEAN market overall. He's been with AWS for 7+ years. He's been working. He's actually had a startup of his own. He's been a co-founder. He plays a lot of interesting games. The Last of Us is an interesting game. Hello, Kashur. Um, he plays The Witcher 3, Warcraft 3, TFT. So currently he plays Disco Elysium and Coffee Talk. So nice to learn that. Nice to know about that, Antoine. Um, Jumping straight into what we hear at AWS as part of the game tech team, what do we hear from developers? Almost everyone wants their servers to scale. They want the ability to scale their games in a manner that allows them to um, to be efficient and to be able to manage their games with the least amount um, of effort. Now, game developers are imagining future games that delight players, and they require infrastructure and solutions that are able to support their vision. So, whether you are building a Web 2 game or a Web 3 game, you need servers that can scale to tens of millions of players anywhere in the world with ready to made. I mean, as much as managed infrastructure to take away the overall undifferentiated heavy lifting, and it also is something that should help you accelerate your development and go to the market with your game as soon as possible. So these are things that are very important. With so many cloud services, it can be challenging to know which service to use and what, and we can help you with the right guidance there. Developers also have a lot of efforts. They spend a lot of time building these games, and then you have to spend additional time handling infrastructure. So it would actually help if you can offload any of that to a managed cloud service of sorts, and that's really where we come in. Moving to quickly introduce AWS for games. So this is a collection of services, solutions, people involved to help you, the game developers, with anything that you need to build, run, and grow your games. So we obviously offer global infrastructure. We have the necessary services and technologies that anyone can use, as well as there are various programs that introduce organizations into AWS, providing you with some sort of benefits and sweetening the initial joining onboarding on AWS. We also provide you with support across the expertise. So we are happy to talk to you with a specific requirement, with your specific use case, and we can guide you through how to build your game or your system on AWS through that. So we provide you with all of this information, all of this guidance as part of AWS for games. One thing you'll have to allow me today is there are some formatting issues with the way the slides look today. Some of my animations have been removed because we could not share my screen. So this is running out of the slides that is supported by the platform here, and the slides have removed. The slides feature has removed all the animations, and as you can see, global has a bit of a overlap with the globe there really, but it's all because of some of these transformation that has been done by the platform. So we were talking of the expertise that we bring in. So we obviously have onboarding programs which provide you with credits, onboarding, game tech training. Um, you also get access to solution architects and BDs who can work with you one on one and help you with your game. We provide you with training and educational content, which allows you to onboard on AWS very quickly, as well as we provide you with networking opportunities, which allow you to connect with others in the industry who are AWS users, who are game studios. And we have hundreds and hundreds of game studios in APJC who are using AWS for their games. So we can connect you between those across those individuals as well. We definitely support the games industry. We will be there at the IGDC. So, in case you are also going to be present at the IGDC, please reach out to us and talk to us. We are happy to meet with you and connect with you there in person. IGDX. Yeah. Let's quickly go into multiplayer servers. So, why are multiplayer servers required? Why do you have games that need multiplayer? So players started by playing single player games and challenges that just allowed them to improve themselves in a given game. They would score a certain score today, and then tomorrow they will try to beat their own score. This obviously got saturated very quickly, and now players want multiplayer features. They want to look at the opportunities of how they can challenge their friends, their contacts, someone online who is also able to play with them, um, and make a difference. That kind of creates a social environment and a community feeling. So players have come to expect multiplayer features. That's when you need game servers, which we can also call them as battle servers or world servers or dedicated game servers or dedicated authoritative servers. These are servers that manage your game mode as well as the virtual world or a map that you have. So if you're going to join a map A, you're joining a certain server which is hosting that map versus another server which could be hosting a different map. There are two topologies that are popular with multiplayer game servers. There's a peer-to-peer and a client server. We're going to take a look at that right after this. Compared to peer-to-peer, dedicated game servers or basically client server dedicated game servers provide lower latency, better reliability, and better security, and the potential to build in cheater detection there, which eventually translates into happy players. So this was a slide which was animated, and if you can just visualize that there is a top section of the text over there, which is registration, sign in, and all. Let's keep the top section separate and the bottom section separate when we look at this slide. So let's come to this. If you start a game, you would run what is called as game services, and you may also host your multiplayer game servers. When a player one arrives, the black device, they would connect over HTTPS. They would register, they would sign in, they would perform the authentication. A session would be created for them. They would enter the lobby, see any promotions or any events, stats and leaderboards. They would see everything that they have done in the game. Now they may now go in to play a certain game mode or a certain game map option. They would then be go. They would put in a request to get matched. A game would be available. A game manager would be able to identify a game for them with the matchmaker, with their skills and the rules necessary, and they would then be connected to the multiplayer game server. So that is when they would now have a TCP or a UDP based direct connection with the multiplayer game server. But now this is one player who has still connected in. So now there would be another player who joins in, who would also perform registration, sign in, authentication, session management, lobby, stats, everything. This player would also get into matchmaking. They would also make a request to join a multiplayer game. That is when that player would also get matched into this game, and they would now connect over TCP or UDP to the same server. This is when the player sessions are created, a game session is created, gameplay is initiated, and then they can play that game, they can perform the activities that are supported in that game. This will involve map updates, broadcast, game telemetry. Everything is taken care of by the multiplayer game servers. There is also player services. There can be chat, audio, video chat that may be supported by the system. And there is also cheater detection where it checks for anomalies. If you didn't have a bullet, how can you have shot a bullet from your gun? Kind of basic, some level of checks depending on what level of cheater detection the server is designed to perform. After the game is completed, they would actually they would submit game reports. The game reports would be collated at the game services, and any anomaly detection that has to happen before it gets written to the database will also be performed at the game services there. So this is a classic, a very simplified example of client server multiplayer gameplay. To Garibaldi's question, yes, that is correct. I'm going to actually bring in the next slide, which talks through that. So when we look at a typical peer-to-peer multiplayer gameplay, you would have one player. You would have, say, the player who has a black device connect into the game services and perform the same set of initial activities that they may do, like registration, authentication, lobby, stats. They would choose a game mode, they would get matched. Now when they get matched, a game could be created for them. Now there could be other players who also join in, who also sign in, and who also choose the same game mode and the same game map, and they are all now matched into the same game. This is when there is a host who gets elected, and this, let's take an example of the blue device here. If that blue device is the host, the blue device will now initiate a connection to black, to orange, and to pink. Same way, each of these will now create a peer-to-peer direct connection with all the other players in that game, and then they will proceed in the game. This is where their player session, their game map, game sessions, everything gets created, gameplay is initiated, their maps are updated, they would be broadcast. So any changes done by the blue will also be visible to black, pink, and yellow. That's how a broadcast would affect. There will also be game reports that get created that will be sent back to the game services, and the game services will be able to collate as well as identify any anomalies in that. Yes, so peer to peer is a poor, it depends on the host and the ability of the host to retain a very sustained good quality internet connection. Not just the host but even the others. So it can create kind of complications when there is a player, there's a host who drops out for some reason. You need to elect a new host, and that new election and all has to happen seamlessly without impacting gameplay. The other three players in this particular example should not have any impact because of one player dropping out, and the programming that can actually end up being complicated as well. So I hope these two, well, yes, it is outdated is another argument, but depends on the effort. Sometimes there are smaller studios who don't have such a massively real-time game that they need a multiplayer game server, and they still look for um, peer-to-peer multiplayer game servers. It may still work for a certain type of game. I can give you an example of a racing game, a car racing game, which has 8 players in a game maximum, that prefers to use a peer-to-peer model as compared to a client server multiplayer model. So there are these choices that developers do, but the idea behind bringing all of this to you is to just explain how we look at and how we understand game servers so that we are all on the same page. So obviously, provisioning and hosting these servers is a challenge. It is important for you to be able to predict what is the kind of player load that you can estimate. How many servers will you require? It's very difficult for you to provision and predict that, as well as host them and keep them ready. Centralized management is equally important. It can get difficult if you have to manage servers sitting in multiple locations. You can have a server in say Europe for your players in Europe. You can have a set of dedicated game servers sitting in the US, and you can have a few in Indonesia. You may also want to have servers in Australia, and handling all of this can actually be an effort involved. You need to have reliable infrastructure. You need to make sure your servers have optimal, good quality internet, reliability, it is secure, it is high performant, all of those. So trying to build a service of your own can be a significant amount of undertaking. As we know, game servers are not cloudy. And by that term, what I mean is they are the biggest problem with game servers is they can be stateful by design. Why I'm saying can is, in majority of cases, when you have a very real time map which needs and which constantly has an update done by every player, and if you have 50, 70, 100, 200 players in that game, it can be extremely difficult for you to maintain the state of the game every second. So there are various strategies. We'll talk about it in the next slide that developers use, but that makes the games very, very flaky because now they are stateful by design, which means they need the state. State is very, very important. They are not what we call as highly available or fault tolerant, which is why they are not cloudy. And what I mean by that is if there is a fault or if there's a crash of that game server, all the players who are connected to it will likely be dropped out and their progress in that game will be lost. So that's really where this is an impact. There are known risks with which game companies go with, which is an underlying issue can cause mass player disconnections. And if this kind of happens again and again and repeatedly, this can be a significant impact on the game reputation, its popularity, and overall business impact. So provisioning for this can be expensive, as we talked about it. It's a lot of effort to predict the number of players. You cannot wait for hardware if you suddenly have a very successful game, as well as having extra hardware sitting idle with no players to play is again a big problem. So scaling is an issue. Under provisioning, over provisioning becomes a problem. The quality of player packing becomes a challenge. How best are you able to pack players inside one instance of a game, and then kind of provide them with the best experience? Those kind of become a bunch of challenges there. When I talk about multiplayer game states, what I mean is there is game data, there can be player data, object data, session data. All of this can be game state. This can be a combination or can be individually. The statefulness of a game is designed is as per game design. This is as per your game's requirement. The game may require that this is a live real time game, and you want that that statefulness. This is also a system design choice because that is how you've developed it, which means you are going to maintain the state in memory or on a on some sort of a storage there. Now, when you try to persist that state, which is if you're trying to write it to a flat file or a database, that itself is complex. There are various strategies that people undertake, like they can, if their game is not a very busy game and not a lot of updates that need to be persisted, you could do real-time state persistence. But if you have a very busy game, you may want to do a batch or a periodic state persistence. Again, there is an obvious risk here where between two periodic persistences, if the game drops out, if there is if there's a problem, players may drop out, that progression may be lost for a small period of time. But then it becomes very important that if you have persisted the state, you also have to be able to retrieve that state and connect those players back, or have the players connect back and be able to continue playing their game. Sometimes in a very large game with 50 or 100 players, that is not practically possible. You can do it for a 4-member player game sometimes, but 200 members, it's very difficult for you to expect them to join back when that same game is brought back. There can be event driven or ad hoc state persistence. So only when this happens or when this milestone is crossed is when I will write the state. You can consider a racing game where between two stages of that race, they kind of don't persist the state. So every time you cross that state is when it actually records that you've completed that. So that's another approach that game developers use. They can also use caching mechanisms using something like Redis or DynamoDB that AWS offers to kind of keep having a live cache, a live update being sent out. So I think I talked about everything around here. Retrieving and querying that game state also needs to be efficient so that you can really there is value in that persistence. Otherwise, being able to persist but not being able to retrieve or query, that's a problem. It can be significant. It can be a significant undertaking if you have to manage the persistent storage yourself as well. So just note all these things. Um, Now we move back into AWS for games, and what we talk about, what we are trying to bring in is obviously all of you would be aware that AWS is a pioneer in cloud services for about 6.5, 7 years. When we after we started, there was no other provider. We were the only provider, only cloud provider in the world. That's something that we innovated, and we've always been the leader in cloud services globally. Um, why do you need AWS for game server hosting, or why do you need the cloud for game server hosting? So AWS provides you with purpose-built managed services. By this, what I mean really is the services that we have are able to cater to all the requirements that game developers have. You may need a high response database, sorry, a low latency database, versus you may want to use an SQL traditional style database. You may want to use NoSQL. You may want to use a certain type of database. You may want to use a certain type of compute. You may want to use a certain type of storage. All of that is purpose built for you, and many of these are what we call as managed services, where you don't have to worry about managing the underlying infrastructure. You only worry about what you are trying to do with that, the application side of things. Obviously, we have the most extensive and the reliable global infrastructure with millions and millions of active customers. Some of the largest names in the world are running on AWS. So you can be rest assured these are really, really important um, decisions that they have made to host on AWS. It has been trusted by the games industry for a very long time. We offer you 400 plus virtual machine types, a large, wide variety of compute, memories, networking, storage, DevOps, everything that you need. Broadest networking services that offer highest reliability and widest coverage, global coverage for your games. Um, Many of you may not be aware, but if you've played Fortnite, Fortnite runs on AWS. This is the director of platforms at Epic Games who's actually provided us with a testimony. This is a testimony which is a relatively old one when they had 200 million users, but their eventual user base went about 250 million users and players, and that was also very well easily supported by AWS. You can read more customer stories if you scan that QR code we have there. So when you do game server hosting, I was talking about the game sessions, being able to have the sorry one sec. I'm not able to read that slide. I'm just going to pull it out uh, on my deck as well. So there it is. So the first one is session request. The second is session creation, session management, and session hosting. So when we talk about a simple segment of just looking after the session as an example, this itself can be non-trivial for you to develop. But as an example, you can build the whole thing on AWS without a lot of trouble. You have the ability to choose from a portfolio of options and select the components that work for you perfectly. This is another example of a customer called Milestone. Milestone is they build MotoGP. If any of you have played MotoGP, this is definitely something that talks about game lift and the benefit of using game lift, how they are able to offload some of their effort in managing complex dedicated game servers. Um, Yes, Adam, I'm happy for us to have a connection later on. So feel free to connect with us. We'll definitely be able to help you with that. Um, Adam or even Muhammad Ardhan. Yes, thank you for your questions. We have an option and on the towards the end where you can reach out to us. So we'll really be happy to work with you directly after this. Um, AWS, we touched upon the global infrastructure, but I just want to provide you with a high-level picture. This is how wide and broad the AWS infrastructure is. This is not something that is um, our closest competitor is not close to anywhere like this. We also have mechanisms which build in, which kind of provide you ability to sustain any failures and build your applications to be able to fault tolerant, to be reliable and stable. So all this infrastructure helps with making sure that your players never experience outages because of AWS. So this is just an example of the wide network that we offer. You may be aware about what we call as regions and availability zones. If not, we are happy to connect back and explain how regions and availability zones work. But a simple one is a region is made up of multiple availability zones, and multiple availability zones are made up of multiple data centers. So, as an example, Jakarta has a region, and you have at least three availability zones there, which can be multiple data centers which are spread and isolated. So, a fault in one of them will not impact any others. And the way you would be designing your application is that they are well spread out so that if anything goes wrong with one, the others can still continue, your game can still continue running without impacting your players. In addition to regions, we also have a concept of local zones, which is like an extension of your extension of the region, which goes closer to your players. So there may be a region which is in a certain city, but there may be your players which are remote and they may have connectivity issues to be able to have good quality connection to the region. Local zones creates a small data center, a mini data center closer to the player, and the player is then able to connect to that instead of having to connect a long distance server somewhere. Just saying that we have a lot of local zones already created, and we are already available, and we are hosting many other local zones as well. This is also a great way for us to be able to scale for our customer needs. So, what are the options that are available? And this kind of goes into some of the questions we are seeing about. So, just to quickly jump into this, if you're running a session-based game, you can definitely use what we call as Amazon Game Lift. I'm going to touch a little about the about Amazon Game Lift after this. If you're using a containers-based approach, if your system uses containers, you can also use Elastic Kubernetes Service or Elastic Container Service that we offer for your session-based games. If you have lightweight, real-time turn-based games, you can also use a service we call Amazon Game Lift Real-Time Service. You can also use something called Fargate on ECS or Fargate on EKS. So ECS is Elastic Container Service, EKS is Elastic Kubernetes Service. Fargate is a managed service which is able to kind of operate without you having to worry a lot about the infrastructure and the pains around administering it. So smaller teams are able to benefit out of services like this. If you're designing and developing a persistent world for a massively multiplayer online game, sometimes the network design, the long sessions can be complicated. You can very well use GameLift for that as well. I'm not saying you cannot use GameLift for that. GameLift definitely supports long sessions and it provides you with all the necessary network design that you need. But sometimes we've seen that EC2, the basic service EC2, actually works better for persistent worlds. So that is something that we would also be able to recommend in depending on your situation, depending on your system design. You can obviously use the container services because a lot of our customers are hosting their persistent worlds on containers. So that's all there. If nothing else, if something does not work for you, there's always Amazon EC2 for all type of multiplayer game servers. There's always Fargate on EC2, which is also ECS or EKS for all type of servers we have. Just doing a time check, we are 30 minutes cross. When I talked about purpose-built databases as an example, I mean this is a very busy slide, so let's not go through everything. But there is a use case. I have this use case in the second row down there. For all these use cases, you can use one of those services that we offer. The names of the services are in the bottom there, and the type of service, like is this a relational database? It's a key value database. Is it in memories? It's a search. Is it a graph database? Time series, ledger, quantum ledger. All of this is available on AWS. You can pick and choose. You can use different type of databases depending on what you need. I was running out of space. There are two more services. We also have a managed Cassandra service, which is called Key Spaces. And we also have a data warehouse called Redshift. That is also a very powerful database engine that we offer. So a lot of this, if you're using any kind of database, you will be able to find something on AWS which will help you run your game efficiently. Obviously, being a cloud provider, we provide a content delivery network. We provide you protection against any sort of data breaches, DDoS events, ability to create firewalls in front of your, have the ability to secure the perimeter of your infrastructure. You have ability to write CloudFront functions or Lambda Edge to customize certain elements, certain behavior of your CloudFront distributions. Firewall Manager obviously adds up to some of the security offerings. Beyond all of this, one of the service that most game servers, game studios have benefited from and have loved is AWS Global Accelerator. So the Global Accelerator brings the benefit of our 400 plus different points of presence that we saw in the global infrastructure slide. So it brings these points of presence. It uses these points of presence to reduce the latency between your player and your server. So if your server is residing in a European region, and if your player is in Jakarta, as an example, we have a POP in Jakarta which will traverse the AWS backbone, which is a very fast backbone versus the public internet. So your player will be connected to the nearest POP, and the POP will traverse the AWS network to reach your servers sitting in Europe. So it reduces the latency that the players would experience by using Global Accelerator. Global Accelerator also provides a mechanism with fault tolerance, so it is able to identify if you have fleet running in region A and in region B, and if region A is not available for any reason, it is able to direct all traffic to region B, and it still makes sure that your game continues operating. These are some ready-to-use game tech solutions, especially the game analytics pipeline, the one in the middle. This is something that a large number of our customers are using, and they have benefited from. Almost every game developer needs game analytics pipeline, and this is something which is ready to use, designed for game developers, game studios, and it's something which is low effort, high value kind of an offering there. I have been talking about GameLift, so let's actually take a look at GameLift, try and understand where GameLift fits in. So it's obviously a low-cost game server hosting service, provides you with low latency connectivity. It is highly available and it provides you with flexibility as well. We'll take a look at it quickly. Unfortunately, as I discussed, some of the animated slides are not working. So let's think about the game clients here. So when you talk about game lift, this is kind of at a high level how managed game lift works. So you start with the game clients, which initiate a connection to the game backend service. They request to join a game. This is when they can be put forth to GameLift Flex Match, which is our matchmaking service, which is built into GameLift, free, no extra cost associated with it. It allows you to configure the rules the way that you prefer, to match your players. You can configure all of that in a simple JSON. It uses its mechanism, its algorithm to match your players, and then it is added to what is called as a game lift queue. Sorry about that. That queue icon seems to have been removed by the slides, but there's a queue there, which is able to further identify the best region for your player. So if you have fleet running in US West, there's a fleet running in Europe and a fleet running in Asia. Based on where your player location is, based on the latency information, the queue will place your player into that right fleet. After they are placed in that fleet, the client will now directly connect to the server over TCP or UDP, and then initiate their gameplay. So this is kind of everything in the box is taken care of for you as an example, and that's really what we're trying to highlight to you. So when you have a multi-region fleet, as I was just talking about, what you can see here is in the center, there is the game lift home region. Let's say that is in Dublin in Ireland somewhere. You may have fleets across the globe like this, and all of these fleets complement your main home region. The home region is where everything is based on. So when a player requests to be match made, the server still is able to create a matchmaking session, is able to identify which fleet this player would have the best experience, and then the server creates the game session on the fleet location that is closest to the player. So how does it work with the cost? So when we talk about infrastructure, we talked about provisioning and scaling challenges, because if you have a successful game, you now need more infrastructure. You can't wait for orders to be delivered to your data center and then prepared and hosted for your game to run. So there are various strategies that AWS offers. You can actually create a fleet, and based on the number of players who come in, it can be scaled out. So this is what we call as target based scaling. So if you are serving more players than, if you have more players, if the demand for the game is high, the game lift will automatically scale your fleet, and it will actually provide you with more game instances for your players to connect into. You will only pay for as many resources or as many instances that you're going to stand up. So when the player load goes away, the fleet will auto scale itself back to a smaller size, so that you are not paying for unused idle resources. So that's something that automated scaling provides you with. It provides you with the ability to handle peaks and troughs within your game. Um, Packing is another important element we were talking about. So yes, it allows you to have multiple game sessions into a single instance, into a single server. So if you have 50 different game sessions, depending on your game, how busy, how resource intensive your game is, you have the ability to host multiple game servers in a single instance. Each server instance can now host up to 200 players, again, depending on the ability of your application to manage the resources properly. So it provides you with packing mechanism that allows you to reduce the cost of infrastructure there. And the third, this is spot instances, where what we have is this is a commercial an offering that AWS offers, which is, if we have excess infrastructure lying in our data center, we make that available on much cheaper prices. That is what we call as spot. There is an algorithm in GameLift which is able to take the benefit of spot instances and provide you with excess infrastructure at lower than the pricing that is published out. There is one thing that we need to be careful about: is spot instances can be taken away with a 2 minute interruption window. So you need to have that mechanism built in. But um, GameLift has an algorithm which is what we call as Fleet IQ, which is what is able to identify which instance is likely to be interrupted, and that instance is where we will not push your game, your players into. After one game has finished, that instance is likely to be scaled out. A new one is supposed to be brought in, and then your new players will be connected to that one after the old one has been taken away. So there are these options which allow you to run your games in a very optimal manner, with the right scale, with the right cost that fits your requirement well. I talked about flex match and I talked about matchmaking. Here's an example of a very simple matchmaking script. This is fully managed, customizable. You can build your rules. You can build your latency-based matching requirements. You have the ability to relax your rules, so you can broaden the match if the match was not found in the first available seconds, minutes. Um, Flex Match also supports matching players to backfill. If a player drops out of a game, you have the ability to backfill the player if the game necessitates a minimum number of players to play. So we talked about game lift. How easy or how difficult is it for you to get started with it? So there's a ready solution that we have built. This is something. This is available on the QR code. It's a GitHub repo. So you have the ability to see the source code. You can use that as a template and build on top of it. This is a multiplayer session-based game that is hosted on GameLift. It is built, it is designed and built as a serverless game, and what we mean by that is we offload the compute administration to AWS. AWS. All we need to do is provide our code, and the code is run by AWS without me bothering about what operating system, what patches, what security. Everything is taken care of. So serverless runs on something called Lambda. We'll take a look at it in an architecture right after this. So It's a serverless architecture fully managed by AWS, hosts your game backend and game servers for you. So let's take a look at that. So this is something that is built. I'll run deeper into that architecture in the coming slides. But this is hosted in multiple regions. As an example, provides you with latency-based matchmaking. It has all the scripts and infrastructure as code templates, so you can quickly start using it. Our service called AWS Cloud Formation helps you build and design your infrastructure via code, and it provides you with Cloud Formation templates to start working with. You can customize it further. You can build on top of it. You can add and make changes to that existing code. It is available to you as a sample. So the code starts. This is the first step that happens. That is, the game client connects into a service called Amazon Cognito, which is where our user identity management. It's a user identity management tool, management system, management service. The player would identify themselves with Cognito, and Cognito will provide it with credentials with which the game client is now able to make call to API gateway to request to be match made. The request to be match made is used by is picked up by a lambda which has the logic which identifies the player um, through the credentials that were provided, and then it is able to check in a database for the skill information for the player level information, any statistics that are required to run to do a good match. Now this data is extracted from the data store and it is pushed out to GameLift. The GameLift matchmaker, that is Flex Match, now uses that information to match this player with a proper with a instance game server instance that is running in an Amazon GameLift fleet. Once a match has been made, this has to be notified back to the system. So there is a notification that is number 7. The number 7 is it sends a game lift will report to SNS, which will create a notification and trigger another lambda, which is number 8. So which is number 8. Um, After the ticket has been processed, the information is stored in a DynamoDB database. This is information that is required by the game client to be able to connect to the game. So it now has the information, it has the server port, it has the server IP, it knows what key it has to use to identify itself, and then it is able to make a connection directly to the game lift fleet. So it starts playing the game from here. So this is an example infrastructure that we have, which also provides you with the last bit, which is monitoring. So CloudWatch, the last element that was just added, that provides you with a visible visual for all your metrics. This can be in-game metrics as well as infrastructure metrics that we provide you as visibility to your infrastructure there. In addition to GameLift, I want to touch on a quick new service, a new offering that we have called Amazon, that AWS Game Kit. Now, this is something which is an open source solution again and enables you to integrate the Game Kit with your Unreal Engine, with Unity Engine. It provides you with a game client side mechanism to be able to connect to the backend, to be able to connect to an AWS service seamlessly. So it has ease of discoverability, ease of use. You are abstracted. It abstracts the complexities of having to connect to your infrastructure backend to do various activities like maybe able to store an image or retrieve an image. This could be a screenshot that the player has taken inside the game that needs to be stored somewhere, or it has to be retrieved when the player requests for it. You can just use GameKit without having to bother about having to create all the rest of the connectivity to the service, authentication, and connection. So, as an example, again, the box on the right is something that is fully taken care of for you. As a developer, you would use GameKit within your game engine, like Unreal or Unity. You would build the interfaces, you would use the interfaces to make whatever calls you need to make to the infrastructure behind. and it will be completed through a cloud formation template by GameKit for you. It will build this template for you. um, Now, this, as I mentioned, it is available on Unreal and on Unity. So you have the ability to use identity and authentication. You can use the achievements. You can use this for achievements. You can use for game state cloud saving. You can use it for user or player gameplay data saving. So you have various features that are readily available. You will find it easier to quickly do this using GameKit there. That sort of completes what I had to talk about. As I mentioned earlier, we will be attending IGDX. So there's Alvin and there's Antoine. Antoine is on this call as well. They will be at IGDX. So feel free to scan there and submit information so that we can connect with you directly. I see that there are a bunch of questions. One of them is talking about bills. So this is a pay as you go model. AWS uses pay as you go model, and you have the ability to control what you are doing. Many times when people talk about bills, they are talking about bills because they have not considered, they have not thought about it. So think about it this way. If you're ordering a server, and if you go to a prominent provider site and instead of one server, you end up adding 10 there. If you add up a zero there extra, you end up getting 10 servers and you end up paying for 10 servers. Many times people make such mistakes when they launch infrastructure. They do not start and stop when they don't need. They don't scale properly. They try to use AWS just like a data center. And this is where we have seen most customers have bill shocks. We are happy to help them with their design, with their ideas. We are happy to navigate around their system architecture and make recommendations of how they can save costs. Cost is one of the most important pillars for AWS. So if our customers have the need to optimize their cost, we have specialists who will help you review your architecture and provide you with recommendations with which you can reduce your costs further. So that is something that I can assure you about. I have been a customer before I joined AWS. I know how important it is that we have our budgets managed well, and AWS provides you with mechanisms to control and help with that. um, AWS, is AWS indie friendly? Yes, very well. Please reach out to Antoine. Antoine has commercial offerings which can help with getting onboarding with your onboarding quickly, or also help you with some sort of mechanisms for funding, for to be able to host your infrastructure, to be able to host your game efficiently. Um, One of the questions is to benefits of each server in all of the three types. So I think you're talking about the servers, the different hosting solutions that I had talked about there. um, there are different benefits depending on what you are using for your design. So I'll be honest here. I've seen a lot of developers moving into a microservices based design or a container based design just because they want to use that in a resume. So if there are those requirements, then the benefits can be very difficult to match. Like the benefit only is that okay, you will be able to say that, oh, I've used this service. Now there are the others, the majority of developers who actually design their system for the given architecture. So when they want to use containers, their system is built and designed for microservices. They have all of their components built as microservices, and that is when they're able to benefit out of a containers based solution. So we provide you with that. If your design is accurate, you will be able to host that on our container services. Both of them have different benefits of each. We can go deep into that. Let's say you can't use containers, you still have GameLift where you can still host your process. Everything else is taken care of for you. All you do is you bring your build, you say this is my server, run this. It will be run for you by GameLift, and your players will be able to connect to that server. So that's how easy it is made. You also have the ability to choose EC2, which is our basic service, which means it provides you with a virtual machine. Now you go ahead, configure it the way that you like, host your application on it, your players will be able to connect to that. So there are these benefits depending on what you're trying to achieve, and that's really how you will be able to manage with. I hope I'm answering the questions. If anyone can just confirm that. Adam, we are developing an. So Adam, I would really be happy to connect with you. Me or Alvin, we should be able to help you with your tech stack. Definitely based on what your game requires. So happy to connect with you after this. That's really what I have. I hope you were able to capture the QR codes and information and links. I think I've touched on every question. Arya, are there any other questions that you want me to answer?
Yeah, I think you have answered all the questions from
Okay.
our audience. But if anybody want to ask more questions, feel free. We have still have 4 minutes left. So
Yep.
yeah, if anybody has any questions, feel free to ask. And for as for Nirav, thank you very much for the presentation. It was really great. And yeah, I think if anybody wants to know more about AWS game tech, just you can meet them at the IGDX. So yeah, so no more questions, I think.
Okay.
Um, so yeah, that's it then. Do you have any closing statements?
Thank you very much, everyone, for your time. I hope this was helpful. And there are a couple of things we just want to make sure that you understand that we understand what you're trying to do. We have a good idea to make the right recommendations and to guide you through on your journey on the cloud. So please reach out to us. Very happy that you could join in today. Looking forward to seeing you all in person. Thank you.
Thank you, Nirav, and thank you everyone for watching. Nirav, I hope to see you again, and
Sure.
goodbye, everyone.
Thank
Goodbye.
you, Arya. Thank you.
You're welcome. Yes.